This is 8.2 part 2. We're going to continue with this example over here. I just finished finding this angle over here. We don't really need it actually. I just did that because sometimes you might not know what to do because you're missing a part and it's right in front of you. You could simply find the other angle and it might open up other solutions for you. But in reality, all we needed was to label our triangle and to see that we had two angles, and one side opposite to one of those angles. And that allows us to use our sine law. We can use our sine law to find the missing side over here. When we're using the sine law to find the missing side, we want to write the ratio so that our sides are on top. So we will write b sine b is equal to little c over sine of angle c. And so that would give us b as our unknown over sine of angle b, which is 52 degrees. Right? This is b our unknown. The opposite side is 52 degrees. Is equal to, we know side c, 17 over sine of angle c, which is the opposite side of side c, of 45. And so I'm just going to continue the work here. To solve for b, we would multiply both sides by sine of 52. In other words, we'd be sending the 52 over to the other side. So we'd get sine 52b over sine 52 is equal to 17 sine 52. I usually write it like this. I usually typically I put the whole sine angle in bracket, divided by sine 45. The sine 52s would cancel out because sine 52 over sine 52 is just 1. So you would get b is equal to, what I would do is do your sine 52 first, press equals, then do divided by sine 45, press equals, and then do times 17. And your final answer would be, if we're rounding to 2 decimal places, 18.95 inches. And so you'd write a therefore statement as well after. You might have named this side A instead, and this side, and this would have been angle A. It would have still given you the correct answer because you would have been using the correct pair, meaning the opposite side and the opposite angle. So it doesn't really matter what you named it as long as it was consistent. If this is angle C over here, angle C over here, this is side little c. If this was angle A over here, you would have called this side little a. So it's all relative. That means that if you named it the other way around, you would have still had the correct answer. You would have had that your b is equal to 18.95 inches. Let's try this example here. Let's see what we have. So this is another scenario where we have two angles and a side that's opposite to one of those angles. And we're looking for this side here. Can we do it as is? So we want to find x. Now the problem is, if you want to find an unknown side, you should probably have the angle opposite to that unknown side. So let's first of all name our triangle. This is side x, so we'll call this vertex x with angle x. We'll call this y. We'll call this z or z. And so this is our uppercase y here. This is our lowercase y and lowercase z. So do we have enough information to find x? Well, we do. We actually can get angle x over here. This is a case where you would have to do 180 minus your two angles, 68 plus 42, to find angle x. So we would get angle x is equal to, and again, that's because angles in a triangle add up to 180. Minus 68, minus 42, we get 70. So we basically needed two angles. We have two now. We want to find x. So usually if you're looking for a certain side, you need to know the angle opposite to it to find it. So now we can write our sine law. We can write that x over sine x is equal to, let's say, y over sine y, uppercase y. So we can say that, and that should be big X here, this should be little x. We can say that little x over sine of 70, and the reason I'm writing it this way again is because I'm looking for a side, so I write the side on top first, and you have to be consistent. If you're doing sides on top, all sides have to be on top. Is equal to side y is 20 over sine of angle y, which is 42. I can solve for x by multiplying both sides by sine 70, meaning sending 70 to the other side. So sine 70 times x over sine 70 is equal to 20 times sine 70 over sine 42. Cross sine 70s out, and so we get x is equal to, so do your sine, and it has to be degrees mode again, 70 equals, divided by sine 42 equals, then times 20, and we get, if we want to round to the two decimal places, 20.09. centimeters, and you can write your therefore statement. So we did have two angles and a side opposite to one of the angles, but the problem is we were looking for angle x. So we needed to know the angle opposite to x to use it in our formula here. Otherwise we'd have too many unknowns. You only really need one unknown. You need to know three things. We had angle x, angle y, and side y. So actually this should be lowercase y, and this should have been uppercase y here, because the angle is always the larger letter, the uppercase letter. So we knew these three things, and we didn't know that. So three known things and one unknown thing, unknown variable, will allow you to find that unknown variable. So this is where we knew at least two angles and one side. Let's go take a look at a few other examples, where this time we know two sides and one angle. And in this case, we're looking for missing angles. So in this example over here, we're looking for a missing length. And notice we wrote the lengths on top with the small letters and the angles at the bottom. Here we're going to be looking for missing angles, so we're going to write it the other way around. So we're looking for angle x over here. So we're going to name our triangle. This will be called vertex x. This is side x. We can call this, and they don't have to necessarily match alphabetically, but this could be vertex y, side y, and this could be vertex z, side z. Let's see what we have. So we have two sides and one angle opposite to those sides. We're looking for angle x, and we have, well, the side opposite to angle x. So we can make an x here, we can use our sine law in this case. We're looking for angle x, so we're going to write it this way. We're going to write sine of angle x over side x is equal to sine of angle y over side y. And so that will give us sine. And I didn't have to call this x just because it was x here. I could have called this big A, made this side little a. And I could have called this b, made this side little b, and c, made this side little c. I didn't have to make this big x just because the x just means there was something unknown there. That's all that means. And I'll do that in the next triangle. Sine of x over 18.9 is equal to sine of y, which is 38, over 23.2. And so now I need to solve for sine x. So I'm sending this to the other side. And so I multiply everything by 18.9. So 18.9 sine x over 18.9 is equal to 18.9 times sine 38 over 23.2. And so I can cross the 18.9 out here. I'm going to continue to work over here. I get sine x is equal to 18.9 sine 38 over 23.2. And so I get that. Now normally I wouldn't write sine x over and over again, but I'm going to do this because I'll show you why. I don't want you to get confused here. I get that sine x is equal to, so let me do that, sine 38 equals, divided by 23.2 equals, times 18.9 equals, I get 0.502 about. That's approximation. I'm going to leave my full number in the calculator. I'm not going to clear it yet. What I'm going to do now is notice this is sine x. This is not x yet. To find x, I need to do the inverse sine of this value here, 0.502. I leave more decimal places because if you round too much, your angle is going to be too far off. So I left my answer in the calculator. All I'm going to do now is press my second function button, inverse sine of answer, or of 0.502, and you should have left more decimal places. And I get, if I round to 2 decimal places, 30.10 degrees. So when you're solving for the angle, the first time you solve for it, you don't get the angle right away. You get sine x. So you have to do the inverse sine of that whole thing, the inverse sine of basically this, to get the actual angle over here. If you forget to do that, you're just going to get the sine of the angle as opposed to just the angle itself. So in the next video, we're going to do question B. And then afterwards, we're going to start exploring some word problems using the sine law.